Hello everyone. Today we are going to discuss pancreas in terms of anatomy and physiology. First, where exactly pancreas is situated. Pancreas is situated or located in the abdominal cavity, just below the stomach. Primarily, pancreas is not an endocrine gland. See, actually it is a mixed type of gland consisting of two parts, that is exocrine part and the endocrine part. That endocrine gland or the endocrine part, the main function being to produce digestive juices. The hormone producing portion of the pancreas that consists of clusters of cells that resembles the islands, or they are called as islets of Langerhans, functions as an endocrine gland. Each islet is composed of beta cells which secrete insulin, alpha cells which secrete glucagon, and this both concerned with the control of blood sugar level. See, actually there is one more third, that is delta, but actually still their functions are still not known, so we won't discuss much about delta cells or their secretions. Here, the pancreas and its hormones. Islets of Langerhans are specialized pancreas cells that secretes insulin. See here, two types of pancreatic cells are available. One, that is so here there are basically two types of cells are available. One, that is alpha cells, next one will be beta cells. So that's insulin secretion portion, that is beta islets of Langerhans. So it secretes insulin, which is made up of polypeptides. So it includes 51 amino acids. Again, it will be in a form of two chains, A chain that constitute of 21 amino acids and B chain that constitute of 30 amino acids. Prior to the formation of insulin, there were formation of precursor proinsulin with 84 amino acids, and after that, from that some amino acids were removed and insulin was secreted. The major functions of insulin, that is related with the blood sugar level. It reduces the blood sugar level, and we used to call it as a glycogenesis. The process is glycogenesis. We will discuss that. What is glycogenesis? See, we can understand glycogenesis. It forms glycogen where in liver, so that the free sugar which is available inside the blood, that may be come from the food material, which will be again transported to the liver, and over there the glycogen will be formed, and that glycogen will be stored further for future use. In many conditions we may not have a food. In those associated conditions, that glycogen may undergo breakdown to form glucose, and again that glucose will be released. So it stimulates the manufacture of amino acids into protein. Next one, that is glucagon. It will be released from the alpha islets of Langerhans, and glucagon is composed of 29 amino acids with 3450 Newton molecular weight. It increases blood sugar level, that is with the help of glycogenolysis and gluconeogenesis. See here, one thing is clear, that these two, that is insulin and glucagon, they may work exact opposite to each other. Insulin, that is responsible for the reduction of blood sugar level. Whereas glucagon increases the blood sugar level. Actually, it depends on the certain physiological conditions where it is necessary. Okay, how exactly it will be balanced? Suppose whenever there will be a elevated blood glucose level, pancreas will be stimulated to release insulin. Now insulin lowers blood glucose level. How? That blood glucose which is available in the blood, glucose is available within the blood, will get transported to the liver and it will be get converted into the glycogen. Whereas the exactly opposite condition where we can see that low blood glucose level, again pancreas will be stimulated to release glucagon, and that glucagon it acts on the liver cells where exactly the glycogen were stored, and this glycogen may undergo breakage or may undergo lysis to form blood glucose, and that blood glucose will be liberated into the blood of the systemic circulation. See, I have mentioned the P, you can see here. Actually, in starting days where exactly we will again discuss diabetes mellitus, and it is related to the diabetes mellitus and the insulin. In starting those days where it was not available from the humans, in those cases insulins were available or developed from the pea. So I mentioned over here. Here we can see there are three different cells, that is glucagon, insulin and the somatostatin. In this case, that is somatostatins. Okay, so we were discussing glucagon. It is released from the alpha cells of the pancreatic islets. When it will be released, there will be a decrease the blood level of glucose during exercise, and mainly in the cases where protein meals stimulate the secretion. Generally, somatostatin and insulin inhibits the secretion. It raises the blood glucose level by accelerating breakdown of glycogen into glucose in liver, and that is called as the glycogenolysis, converting other nutrients into glucose in liver, that is gluconeogenesis. So the basic difference between glycogenolysis and the gluconeogenesis, that is, see in the previous condition, that is glycogenolysis, the glucose will be formed from the glycogen, whereas in the cases of gluconeogenesis, the glucose will be formed from the other than glycogen sources and will be released into the bloodstream. Second, that is insulin from beta cells of the pancreatic islets. See, this is these three, 1, 2 and 3. It belongs to the secretion or the roots, the regulation portion. This is actually the physiological actions. So here in insulin we can see that increase the blood glucose level. It is the stimulus for the increase the blood glucose level is stimulus for the insulin to release. So acetylcholine will be released by the parasympathetic vagus nerve fibers as well as arginine and the leucine, that is two amino acids with glucagon, GIP, H, that is the growth hormone, and ACTH stimulate the secretions of heat. So somatostatin inhibition can be seen. Now that physiology, that functions, that is it lowers the blood glucose level by accelerating transport of glucose into cells, converting glucose into glycogen. Now glucose will get converted into the glycogen, and the process can be called glycogenesis. Right over here, glycogen will be formed, and decreasing glycogenolysis, that is the breakdown of glycogen into glucose, will be substantially decreased, and gluconeogenesis will be increased, that is the formation of glycogen other than the glucose sources. It also increases the lipogenesis, that is the lipogenesis, and stimulates the synthesis of protein. So here in cases of lipogenesis, it inhibits lipolysis. Next, third one, that is somatostatin, that is from the delta cells of the pancreatic islets. You can see here where exactly they are located. Pancreatic polypeptides inhibits the secretion of it. Physiology, welcome to their functions, inhibits the secretion of insulin and glucagon and slows the absorption of nutrients from the gastrointestinal tract. Next one, diabetes mellitus. Disorder related to the pancreas, that is diabetes mellitus. This is the most common endocrine disorder. The normal range of blood sugar level should be ranges between 80 to 120 milligram percentage. Here it could be of two types. One will be insulin dependent diabetes mellitus, that is IDDM, insulin dependent diabetes mellitus, that is type 1 diabetes, and again it is less common but more severe. Second, that is non-insulin dependent diabetes mellitus, that is NIDDM, that is type 2 diabetes. And third, that is gestational diabetes, generally usually disappears after the childbirth and it can be seen with the pregnant woman. Okay, so this is what today we will discuss, right? What we have discussed today? Pancreas in terms of anatomy and physiology. Thank you.